Hello, welcome student, and in previous lectures we have discussed the PN junction diodes. PN junction diode means a metallic connector is connected, or PN junction is provided to the metallic connector is called as a PN junction diode. And the PN junction diode is the symbolic representations of that PN junction diode will be like this. This is the PN junction diodes. This side is a positive and another one is a negative sides. Then the PN junction, if diode, it means they have two electrodes, one is a anode and another one is a cathode. Anode is a connected as a it works as a positive terminals or a positive, and anode cathode it a negative terminals. And in these lectures we are discuss the biasing of PN junction diodes. If it is discussed as like when we are discuss the PN junction biasing of in the PN junction. In these lectures we are discussing the biasing of PN junction diode. Please take the heading, the biasing in PN junction diode. PN junction diode, it means two electrodes, anode, two electrodes, anode and cathode. Here cathode is represent the negative terminals like a N type of semiconductor, and anode is represent the positive terminals like a P type of semiconductor. The first heading is forward biasing or forward bias. The forward bias, it means when the positive terminals of the external supply voltage is connected to the anode. The positive terminals is connected or is connected to anode, is connected to anode, and negative terminal of the external voltage is connected to negative terminal is connected to the is connected to, that is cathode, and this arrangement is called as a forward biasing of PN junction here. Then what if consider this is the PN junction here, that is P type and N type semiconductor. If we apply some metallic connector, this makes a PN junction diode. Then this is the depletion layers or the depletion region. This will be positive and this will be negative. The positive terminals of the external power supply, external voltage is connected to the anode. It means a positive P side or P regions having the lot of holes. Then the negative terminals of the external source of the voltage is connected to the cathode of PN junction diode. Then this will be negative terminals, this is positive terminals. The positive and positive gets repelled to each other, and negative gets also repelled to each other. Then the force by the positive terminals from the anode and negative terminals from the that means electrons from the cathode are applied on the depletion layer, that will be deflection layers. The force from the N type, this will be like as N type PN junction, and this will be P types. The force or they will be moves towards to the electrons will be moves, and holes will be moves towards to the depletion layers, and the regions, depletion region or depletion regions or depletion layer will be reduced. or decreased, the PN junction has a low resistance. The PN junction has low resistance. Then if the junction is a low resistance, they make allow to flow a large amount of currents. Then the depletion layer or depletion region, the depletion region is decreased, then a PN junction has low resistance, and it allow to flow of large amount of current, and it allow to flow of large amount of current, Okay, can you digest what will be said in the forward biasing? When the positive terminals of the external power supply is connected to the anode and the negative terminal is connected to the cathode, then the gates will be repelled, and the negative or electrons from the N type of the PN junctions and holes from the P type of the PN junctions gets attracted or gets moving towards to the depletion regions, and this depletion region is decreased in the PN junction. Then the PN junctions has a low resistance. If the junction is a low resistance, then they allow to flow the large amount of currents. Then I will be drawn the voltage and IV characteristics. IV characteristic, it means the current and voltage, graphical representations of the current and voltage here. Along the x-axis the voltage V, along the y-axis this will be current I. When we are applying some minimum value in the forward bias, in the initially current is a very low. Initially the current will be very low and suddenly the goes increased. The initially current will be very low, they suddenly goes increase at the point which a current is sharply increased. At the point which current is sharply increased, this point is called as knee points. This point is called as knee point here. And the corresponding voltage at that point, this voltage is called as knee voltage. The corresponding voltage at the particular point, at that point the current will be sharply increased. Then this point is called as the corresponding voltage at that point is called as knee voltage. Then this knee voltage is a different type of the semiconductor which will be taken in the formations of PN junction diode. Then for the silicon, that is a knee voltage for silicon, for SI it means silicon is 0.7 volt, and for the germaniums this will be 0.3 volt. The amount of flow of current in the forward biasing, this will be forward bias regions, the amount of current flow is in the form of milliampere. That means 10⁻³ amperes. This is all about the forward biasing. The connections of forward biasing, depletion layers or depletion region gets decreased. With when the depletion region gets decreased, at that point they will be at that point the PN junction has a low resistance. If the PN junction has a low resistance, they allow to flow of the large amount of current across the PN junction. And we are discussed the characteristics of IV. IV means current and voltage, current versus voltage graphical representation here. If at the initially the current is very low, at a point the current will be sharply raised, sharply increased, and this point is called as a knee point, and the corresponding voltage is called as a knee voltage. This knee voltage is different for the silicon and germaniums or different types of the semiconductor. For the silicon there is 0.7 volt. If we are apply the 0.7 volt of that PN junction diode which can be mixed by the silicon, at that 0.7 volt they suddenly goes to increase the current. If germanium is very low, and we are used germanium a lot of times. At a knee point, a conduction is very high, conduction of the current is very high, and for the control of this, for the limitations of this current, we use the external resistance to exceed external resistance. If it exceeds the electric current एक्सीड झाल्यानंतर हीट वाढत असते. हीट इज ड्यू टू द जूल हिटिंग, आणि जूल हिटिंगमुळे हीट वाढल्यानंतर इट सर्किट गेट्स फिजिकली डॅमेज्ड. दिस इज ऑल अबाउट द फॉरवर्ड बायसिंग्स. Let's discussion the reverse biasing in the reverse process. If a positive terminal is connected to the cathode, just rechanging some words and use as same, then okay, if the positive terminals of the positive terminal of external voltage source is connected to the cathode and negative terminal is connected to the anode, negative terminal is connected to the anode, then what happens? Then the charges which can be produced in the p-type region and n-type region, they gets repel or they gets attracted to that particular ends or particular terminals, and the depletion layers or depletion region gets increased. If the depletion layer, the depletion region increased, the depletion region increased, if the depletion region will be increased, the PN junction has a large amount of or high resistance. If the high resistance, the amount of current will be low, then the amount of current will be low, no current flow. But the small amount of current will be very small, no current flow through it, but small amount of current is called leakage current. Please remember for the MCQ of these leakage current. The definition: when the depletion layers or depletion region is increased when we apply the reverse bias method, at that times the small amount of current will be flow through the circuit, and this small amount of current is called as leakage current. What is the knee? Knee at the point when the current is sharply increased in the forward biasing, this is called as knee point. This will be for most important to asking the MCQs for examiners, and you always keep in mind for this type of the MCQs. This will be most important for the competitive exam also and your board examination also. Then when a applied voltage is increased, let's again we can be drawn the same graphical representation here, but some different manners. This will be current and this is the voltage, applied voltage. This is reverse process and this is the applied voltage and this will be current I. IV characteristics. When we are applied voltage will be slightly increased, it causes the PN junction overheats. But we are drawn the diagrammatic representations here, that is very small amount of current will be flow. At a sudden they also increase. Or also raised the amount of current flow through it. तर या ठिकाणी काय होत असतं, हे दोन्ही तर रिजन वाढतच आहे, बट करंट कसं काय फ्लो होतं, व्हेन अ व्होल्टेज अप्लाइड इज increases then the PN junction gets overheated. ओव्हरहीटमुळे काय होत असते, they will be, it's due to the overheating, the sudden current is a flow very large amount raised. This is because the covalent bond gets breaked, and if the breaking of covalent bonds, the electrons will be gets freed in the silicon or germanium, any type of the semiconductor. If the electrons will be free, these electrons is travels in the conduction band, and if the conduction band have the electrons, these electrons taking the part of the conduction of current, and this is all about that. For the breaking of these covalent bond, this effect is called as avalanche effect. This effect is called as avalanche effect. The breaking of this covalent bond, I will be right here CB. This effect is called avalanche breakdown. Called as avalanche breakdowns. What is the avalanche breakdown? For the overheating or applied voltage will be increased, the overheating of the PN junction diode, the covalent bond between the silicon or germanium and germanium, it gets breaked. These for the bond breaking, the lot of electrons or large number of electrons is the travels in the conduction band. Availability of the electrons in the conduction band, they takes a part of the conduction or current conduction in that semiconductor, and this effect is called as this breaking of the covalent band. This effect is called as avalanche breakdown effects. Gets revised the reverse bias here. This will be reverse bias. ठीक आहे, तुम्ही नोट्स मध्ये तसंच लिहून घेता. Reverse bias. A positive terminals of the external power supply is connected to the cathode of the PN junction diode, and negative terminals is connected to the anode. Then the depletion layers, काय होत असतं मी सांगितलेलं, the depletion layers will be increased. Then the depletion layer is increased, large amount of resistance is it has PN junction has a large amount of resistance, it could no flow of the current. large amount of the resistance असेल तर current flow होत नाही, but a small amount of current will be flow across this junction. This current is called as leakage current. This will be most important. What is the leakage current? And in the certain books they gives the leakage current, and the current flowing in the reverse biasing is in the microampere. That means 10⁻⁻⁶ ampere. What is the difference between the current flowing through the forward biasing and reverse biasing is the forward biasing, the current flow in the amount of milliamperes, and in the reverse biasing the current flow through the PN junction is in the form of in the order of microampere. This is all about the biasing which can be studied in the PN junction and PN junction diodes. In the PN junction we just study what happened exactly in the this type of the semiconductor. In these lectures we are studying the characteristics, the graphical representations of the voltage and current here. Then now we are stopped to discussions of the biasing in the PN junction diode.